Excited that we have you here today. This is the NeuroAbilities Webinar. This is Neurotechnology for Expressive Communication, Current and Future Considerations. And we have an amazing panel today for you to listen to, incredible speakers. Again, my name is Christopher Lee. I represent IAAP, but this is sponsored by the Patrick J. McGovern Foundation, as well as G3ICT. IAAP is a division of G3ICT. And the National Center for Adaptive Neurotechnologies. So we are glad to have you here today. I will be the conductor for today, so I'm going to be hanging out in the background and trying to keep everything on time. If you have any questions, as Rachel said, put it in the Q&A. Definitely use the chat and engage with the speakers. So just a little bit about the NeuroAbilities project. We're a little over a year old now. It's got a great group of advisory committees, but NeuroAbility explores the contributions of neurotechnologies aided by artificial intelligence and other advanced technologies. And the whole point of this is to make it accessibility solutions to improve the lives of people with disabilities. So that's what we're here today about, is talking about solutions that can actually impact people with disabilities. So with that said, I'm going to turn it over to Melanie Fried-Oken, who is a professor of neurology at OHSU. So Melanie, come on, it's your floor.
Hi, good morning, good afternoon, good evening, wherever you are. I am the moderator for this session, and it is my honor to introduce the panelists and moderate what we're going to do today. Next, please. Today, you're going to hear from 4 panelists, 2 clinical researchers, and 2 people who are end users and supported end users. So Bets Peters is a research associate at Oregon Health and Science University, working in a brain-computer interface lab. Dana Williams was the care provider for a man who relied on brain-computer interface. Dr. Amy Dietz is a professor of speech-language pathology at the University of Cincinnati and an expert in the area of assistive technology and aphasia. And Dr. Tom Broussard is a man who experienced 2 small strokes and 1 large stroke that left him with aphasia. We're going to divide into 2 dyads today, where a clinical researcher and an end user will discuss their experiences. Next, thanks. I have the privilege of laying the foundation for today's conversation. We are talking about neurotechnologies and expressive communication. Next. So first, just to make sure we're all on the same page, what is expressive communication? We're going to divide it into 2 areas. The first we're going to talk about is speech and speech challenges. Speech refers to the process of putting sounds together to form words. People who present with speech challenges often have motor disabilities. Then we will talk about language. Language is the process of putting words together to share thoughts. People with language challenges often have aphasia. Now, we're going to use a lot of terms and letters today, so I thought we'd start just by defining some things. The first term you'll hear often is AAC, or Augmentative and Alternative Communication. AAC refers to technologies, tools, and equipment that are used by people with speech and language challenges for rehabilitation and enhancement. You'll hear about the SLP, or speech language pathologist. That is the person who is the therapist who provides the AAC intervention. And you'll also hear the letters BCI, and that stands for brain-computer interface. This is one of the neurotechnologies that is currently being developed, most for individuals with speech and motor challenges. Next, thank you. Now, one of the reasons we wanted to talk about neurotechnologies and expressive communication is because in this day and age, there's a paradigm shift in communication. All of us are using technologies for expression. The general population is now relying on many different forms of communication, not just speech, such as texting on smartphones, emails, or social media on mobile technologies, video conferencing like we're doing right now on laptop computers, and many of our students are learning on Zoom because of the pandemic. All of these are forms of communication. What we're going to talk about today are neurotechnologies that sit at the end of this communication continuum, most often incorporating artificial intelligence and machine learning so we can support our end users. So our goal today, now that you have the foundation, is to discuss the accessibility of neurotechnologies for speech challenges and for language challenges from the perspective of the clinical researcher and the end user. So what do we mean by accessibility? Well, really, we have 4 different definitions of accessibility. We can talk about access to knowledge and learning all about this. We can talk about access to equipment and making sure that the equipment is available and affordable. We can talk about access to the equipment through using our fingers to type or our eyes to move a cursor, lots of different ways for physical control. And we can talk about language and cognitive access. So making sure that there are screen readers for individuals who cannot see the screen, making sure that the language is at a level that someone can understand, making symbols if someone can't read, lots of different ways to access language and thought. So, given that foundation, I'd like to introduce you now to Dana Williams, a certified nurse assistant and end user perspective, and Bets Peters, a research associate and clinical researcher. They will discuss non-invasive brain-computer interfaces.
Hi, everyone. Thank you, Melanie. So I'm Bets Peters. I apologize for the lack of truth in advertising. My hair has gotten just a little bit longer during COVID times than in that photo. I'm really happy to be here today. I'm a speech language pathologist and an assistive technology specialist and a researcher specializing in brain-computer interface. So I'm going to talk a little bit about what BCI is and how it works. And Dana Williams is a longtime caregiver and friend to a man with ALS who used BCI in his everyday life. She has a really interesting experience and wonderful perspective that she's going to share. So I'll talk for a couple of minutes and then we're going to have a Q&A with Dana. So I'll start by talking a little bit about brain-computer interface, or BCI. Melanie introduced augmentative and alternative communication, AAC, and how that can be helpful to people with communication impairments. I'm going to talk about BCI as an access method for AAC. So access method just means how someone uses an AAC system. Some people are able to just type on a keyboard or use a mouse. Other people might use a switch and do switch scanning, or they might use eye tracking where there's a special camera that can watch their eye movements to see what they're looking at on the screen. So all of those methods require movement. Even if it's a very small movement, it does require some movement. Brain-computer interface is another way to control a computer, including AAC software, without any movement. It really is just with your brain activity. And I want to emphasize that BCI does not read your thoughts. It's not going to just, it's not like you can just think what you want to say and the computer will speak it for you. It's not going to, you know, tell your friend what you really think of her new outfit or anything like that. It's just another way to send commands to the computer, just like using a keyboard or a mouse or a switch. You just use your brain to send that signal instead of your muscles. Eventually, BCI may be able to do a thought-to-speech function where you can just think something and have it spoken by the computer, but this is quite a ways off in the research. We're just not there yet. There are two major types of BCI. We have invasive and non-invasive. Invasive BCI requires that you get brain surgery to actually implant electrodes on the surface of your brain that pick up your brain activity. Non-invasive does not require that surgery. The signals are acquired from outside the scalp. Usually there's a cap that you can wear with electrodes in it that just picks up the brain signals through your scalp. I'm going to show a video here that will show what a BCI system looks like. This clip is actually from a story on 60 Minutes a number of years ago that was about Dana's friend and employer, Scott. So I'm going to show this video and talk a little bit about what we're seeing here. Okay. So here we see Scott wearing the cap for the BCI system. You can see it looks kind of like a swim cap. There's a cable that's extending along his shoulder. That's the cords that are connecting the electrodes to the computer that he's looking at. That's what's sending his brain signals as commands to the computer. And so what's he actually looking at as he's using this BCI system? So on this monitor, try to pause it where they're flashing. You can see a grid of letters here and also some commands for controlling the computer. And they're flashing quickly. So there's a few letters and commands that are flashing at once. And what Scott is doing is he's looking at the letter that he wants. So if he wants to type the letter S, he would be staring at that letter S on the screen and paying attention to it. And it would be flashing among all the other letters on the screen. And when the S lights up, he would think, oh, there it is, or he might count the flashes. He's just paying attention to every time that S flashes. And when it does flash, it actually would produce a change in his brain signal, a little spike in the brain signal that kind of says, ooh, that one, that's the one I want. And that's a signal that the computer can interpret as almost a keystroke, as saying that he wants to type that letter S. So I'll start the video again. You can see how quickly these letters are flashing. And here's another view of the cap. You can see some of the electrodes, those white circles on the back. There's a little hole in the electrodes because it does require a bit of conductive gel to be inserted into that hole to get a good connection between the electrode and the scalp. And Scott is using this BCI system. You can see that on the screen on the right in this picture. In the screen on the left is just kind of a regular computer desktop. So that's where he would have his applications. If he's typing an email or perhaps writing a manuscript or something like that, the BCI screen on the right is like his keyboard. That's where he's selecting letters that then appear in the other monitor on the left. And so that's how he would type with BCI. So I hope this gives you a little bit of an idea of how a brain-computer interface works. This video was taken about 12, 13 years ago. So things have changed a little bit since then, of course, but many current BCI systems still look very much like that. There are still a lot of systems that use that swim cap style cap for the electrodes. The grid of letters with flashing characters is still a common way of getting the signals and typing with the BCI. But things have changed a little bit. So that BCI system that Scott used, most BCI systems are still in the research phase. We're doing a lot of research our group, other groups around the country and around the world. It's pretty rare that anyone has a BCI system for everyday use, that they're just using to communicate or for their written language. But Dana, as I mentioned earlier, did work with a man who used BCI for several years. So she has a really unique experience. She has seen this technology in action in daily life for many hours a day, being used for all sorts of different things. So I'm really excited to hear about her experiences working with Scott and working with BCI. So, Dana, so we saw Scott in the video. I didn't know Scott. I know that he was a scientist at the University of Pennsylvania. I know that he had ALS,
Yeah.
and I continued working for a long time, even as he started to have more trouble talking and moving. Can you tell us a little more about him and what he was like as a person?
He was great. He was a very intelligent man. He was a great teacher and a great friend. And I worked with him for 12 years.
You worked with him for 12 years. Yeah, so you had a long relationship with him. And
oh, yes, we did.
And you would work, you worked in his research lab as well as helping with him with caregiving activities. Is that right?
Yes. We went to the University of Penn 4 days out of the week, and then we worked from home on Fridays.
Okay. And how was Scott communicating when you first met him?
When I first met Scott, he was using some sort of eye gaze machine, and it was like he wore glasses, and it was a little computer, like a keyboard that you can see. He can see through it, and it has a little keyboard in there, and he calibrated it with his eyes. We also used the alphabet. So his family broke down the alphabet into 3 parts, which is A to H, I to Q, and then R to Z. And so when Scott was not using his eye gaze machine, we would ask him first part, second part, third part. So if he says the second part, that means I will start with the alphabet, I, J, K, L. When I get to the certain, the letter, he would look at me. And that means, so I basically would have to remember the letter. And over the years, it got to where I kind of knew what he wanted before he even spelled out everything. And also for his yes or no questions, he would look away for no, and he would look at you for yes.
Okay, so he had a computer that could track his eye movements, and he could type on the computer that way. But when he wasn't using the computer, you or someone else would kind of give him options, groups of letters, and then individual letters, and he would use a signal with his eyes to make a selection. Is that right?
Yes.
Okay. And was he starting to have trouble with the eye tracking computer?
Yes, he was having trouble with that. And so we kind of started using the alphabet a little bit more, but it was a little slow using the alphabet, and Scott would get kind of tired using the alphabet too as well. So then he finally learned about BCI, using BCI.
How did he learn about BCI?
So one of his wife, she's a professor at the University of Delaware, and one of her colleagues had introduced them to the BCI system.
Okay. So he learned about this research system through another professor.
Yes.
And so then he started using the BCI. He contacted this research team and had a BCI system that he was able to use at home and at work. Can you tell us a little bit about how Scott used the BCI in his daily life and in different situations?
Yeah, so he used it a lot for work when we went to the University of Penn. He used it for, sometimes he would have visitors come in, and he would use it to talk to, colleagues and visitors. He would also use it to write manuscripts. And he also did a PowerPoint. He always used to, every year he'd do a PowerPoint presentation for the first year medical students. So he would type on BCI on a PowerPoint to create his slides.
Oh, wow.
And also to talk to staff in the lab as well.
Okay, so he used it for all aspects of his work, essentially. So giving presentations and writing papers, writing emails, directing his staff. And then he used it some for communicating face-to-face with friends and family as well?
Yes, he did.
Okay.
Yes.
So on a typical day, how long would he be using the BCI? Is he using it all day long, or?
Yeah, basically like 8 hours, 8 hours a day.
Mm-hmm.
Yeah.
Okay. How did using BCI affect Scott's life? What do you think it meant to him to have that technology?
It meant a lot to him. It helped him communicate better. At one point he said that he could not work without BCI. So it really helped him a lot.
Mm-hmm. So it gave him an option when his other options were kind of becoming harder to use and slower and.
Oh, yes.
What was it like for you to communicate with Scott when he was using the BCI?
It was a lot easier for me because I didn't have to basically check on him a lot. I used to do other stuff in the lab. So I used to, order things for the lab. I used to look up science in the PubMed, scientific magazines and everything. So it helped me out because I didn't have to always check on him as much. Yeah.
Okay, so it allowed him to kind of be working independently over here, and you could be working independently over there, and not have to be communicate all the time.
Yeah.
And so you helped Scott at work and at home. That meant that you had to learn to use the BCI system as well. You had to learn to set it up every day, to put the gel in the electrodes, to adjust the cap, to troubleshoot it if something went wrong, know who to call. What was that like for you, learning to use the BCI system and to support Scott with it?
It was a challenge. It was a challenge, but I knew I had to do it because I knew it meant a lot to him and it was important. I always had, the ability to call like Teresa in Albany and the Wadsworth scientists if I needed any help. And so, eventually I got it. I was, after working with it for a while, I got it. And I kind of knew what to do on my own without even calling them.
Yeah. So this system that Scott was using was still part of a research project, right? So you had a whole staff of researchers that you could contact if something was going wrong.
Yes.
Yeah. Okay. How did the BCI affect your relationship and your interactions with Scott?
Well, Scott and I always had a great relationship before BCI. Basically, it made it less frustrating for Scott, So, and it helped our. We didn't really never have any problems with our relationship, but he wasn't so frustrated like he used to be before using BCI.
Okay. So yeah, and reducing frustration is good for any interaction in any relationship, right?
Yes. I mean, everything, it wasn't perfect. We weren't perfect. We argue like father and daughter sometimes. So, but BCI, it helped him. It helped a lot as far as his communicating.
I think even that says something. If the BCI and the other communication methods that he had allowed him to argue with you, I think that's, that means something.
Yeah.
What were some of the challenges with using BCI? Either challenges that Scott faced using it or things that were hard for you as his support person?
Sometimes, well, some of the challenges were getting a good signal. Sometimes it was hard. I had to move him around sometimes in his wheelchair, maybe position his head, because, you know, the lights are flashing over the screen. So sometimes I had to position his head so he can get, you know, he can focus on that particular letter or number that he wanted to use. And then eventually, Scott was unable to use the system due to ptosis. His eye, because his eyes. So that was some of the main challenges with the BCI.
Okay. So ptosis, that's kind of a droopy eyelid. So it made it harder for him to see the screen?
Yes.
And did he also start to have some difficulty moving his eyes around? So moving back and forth to give a signal or moving to look at things on the computer screen?
Yes, he did. So sometimes, you know, when we did have that trouble, we would sometimes not use it. And we would literally go through using the alphabet again.
Yeah.
Yeah.
And you said he was using that computer for 8 hours a day, a full day. Was that tiring for his eyes?
Yes. And also when we worked at home as well, he had another monitor at home. So when he worked at home on Fridays, he used to BCI as well.
Okay.
At home.
Okay. And so you had to bring the BCI system back and forth between home and work, right? He had a computer in each place that it could connect to, but you had to carry the boxes that the electrode wires connect to and all those other
amplifier, sometimes the gel. Yes.
Yeah. Okay. Yeah. There's a bunch of different parts that have to be put together for this system to work.
Right.
So what are some improvements that you would like to see in BCI technology?
More portable, easier to carry from one place to the other. Maybe the ability to switch over to a different interface type. For example, switching over to the auditory mode when when a patient's eyes get a little tired. That's basically it.
Okay, yeah. So giving him something where he didn't have to look at it when his eyes were tired, it could switch into a different mode and kind of adapt.
Yes.
Okay.
Yes.
And so this system was provided by a research lab and supported by a research lab. I understand that Scott and that you provided a lot of suggestions to help improve this system, that you kind of contributed to the research, you provided notes and suggestions. Can you tell us a little bit more about that?
Not only Scott and I providing data, Scott also had, so his wife had a student who lived in the home, and she was married and he lived in the home as well. His name was Bob Cordillo. So he had a lot to do with it as well, because he provided a lot of the applications that correspond with the BCI. So he contributed as well to the BCI research. He was very helpful, very helpful.
So suggestions from Scott and from you, from friends and family who were watching this system in use. And yeah, so I think that really highlights the importance of involving people with disabilities, people who are going to use this system in everyday life, in the research and development of these systems. You know, we need to make sure that it really does work for what people need to do.
Yes, I enjoyed it. After I got to know how to use it. I enjoyed it, and I love working with BCI. I love working with Scott, and I totally miss it. I do.
Yeah, it sounds like it was a positive experience for Scott and for you, and hopefully for everybody involved.
Yeah.
I think we have reached the end of our segment here. So thank you very much, Dana, for answering these questions and sharing your experiences.
You are so welcome. No problem. You are welcome.
All right. Thank you.
You're welcome.
Well, we're going to move on now to talk about people who have language challenges. We heard from Bets and Dana about individuals who have speech challenges, such as Scott, who had ALS. And now we're going to hear from Amy and Tom.
Hey, thank you. So yes, we are switching gears a little bit after that very enlightening overview on BCI. So thank you for that. So I am a speech language pathologist who does clinical research in aphasia and AAC, and Dr. Broussard is a stroke educator who has a background in academia, but also is a stroke survivor who has joined us today to help us. So AAC and current practice, right now, only about 50% of caregivers report receiving education about AAC approaches from speech pathologists during the first 3 months of their post-stroke experience. And data from the American Speech, Language, and Hearing Association National Outcomes Measurement Systems, a project called GNOMES, revealed that of 862 post-acute patients with aphasia and apraxia of speech, which is a motor speech issue, only 13% receive AAC. However, if you remove the apraxia of speech, the more motor speech issue, only 2% of people with aphasia receive AAC during their time in the hospital, 2%. These numbers represent an incredibly small portion of stroke survivors with aphasia and likely leaves a large portion of people with unmet needs who are unable to participate in their healthcare decision-making, much less reconnect with loved ones, return to work or school, or renegotiate their new identity in their post-stroke life. If you look at this picture, you'll see a gentleman with a physical therapist and likely a physical therapy aide using a wheelchair and a walker to help improve his walking ability. The physical therapist does not wait for people to walk independently before allowing them to move around in their environment. So we ask, my colleagues Sarah Wallace and Chrissy Weisling and I ask, why would we wait until they can fully recover their language system before they can communicate? But we do this all the time. We wait until they plateau, that word that we all use. Well, they've plateaued, and then we give them the AAC system. That's typically what we do in rehab. But I think the answer is simple. They shouldn't. Instead, clinicians should teach them how to use available AAC strategies to help them learn how to compensate for anomic events, so those word retrieval issues they have, because they're going to have them. We don't have a silver bullet for aphasia yet, while guiding them to self-cue spoken language whenever possible. But what we need for this to happen, though, is an understanding of the available and developing neurotechnologies. Generally speaking, there are two interface designs that people with aphasia and clinicians alike have to choose from when considering their options. Today, I will refer to them as grids and visual scenes displays, or VSDs. This video will provide a brief overview of each neurotechnology. And someone please let me know if you can't hear this. I think I clicked the special buttons.
The first one is grid, where you press the button I, feelings, love, all words list, to the category plants, and then flower. To change it to flowers, you go to all forms and press flowers, and then you can press the speak button.
I love flowers.
So as you can see, this interface has a lot of steps to say those simple 3 words. The next is the visual scene display, which I will go to my story, which is me in a flower garden, and I have pre-programmed the sentence I love flowers, so I can point to it and use it as an aid, or I again can press the speak button.
I love flowers.
The first one is grid.
So that was just a brief overview. And now I'd like to bring in Tom to bring in his life experience as a stroke survivor to kind of give us what he thinks, because I can tell you what I think will work and best and what would be difficult for people with aphasia, but I'd like Tom to come in and tell us what he thinks about the grid displays. And so what we have here is a picture of kind of what was in the video of a grid display where you've got all these buttons where you'd have to pick your noun, your verb, and your adjective, and then you'd have to touch the cell where it would speak your sentence for you. So Tom, can you tell us what you think about grid displays as an AAC option and how it is or might have been helpful to you then or now?
Sure. Of course, in my case, I couldn't even use a computer keyboard, so never mind the hunt and peck of the grid display. For people with aphasia, especially at the beginning, it becomes very difficult, what I call confusing, when you're actually looking at a number of texts and activities that are presented in front of you. So it is a lot more difficult to imagine trying to type into that grid in the same way I couldn't type to a computer at the beginning.
So is what you're saying, it might, you imagine if you were presented with this, it would be challenging?
Yeah, challenging is a good way to say that. A lot of the damage to people with aphasia have a speed component. So when we can't, quote, find a word, eventually, if we're lucky, we can find that word. But it takes time, seconds, if not more than that. So again, back to looking at the grid as an example, it would take so much time to make decisions about what I'm looking at and then deciding to press one and then have you go through that whole process again. So speed has a lot to do with it because there's enough damage such that you won't be able to consider, decide, and act all within the typical conversational speed.
Okay. Tom, one thing I often say about this interface type is that I believe it would be like teaching a person with aphasia a new language.
Yeah.
Because you've got all these symbols, and even though you've got words on here that are words that if you were literate pre-stroke that, you know, they would be familiar, one would think. Would you say that's an accurate depiction, that it would be like learning a new language?
Absolutely. When you have, quote, lost your language and you have to get it back again, an awful lot of that happens on the inside because you're seeing a lot of things. You're understanding, for the most part, what you're hearing from other people. The difficulty is that since you can't express what it is you are, quote, thinking about and wanting to say, you're going through all that on the inside, beginning to understand that you've lost that language and you have to get it back. And that is the issue. The activities themselves is a large part of it. But you go through that process in your head as you see what's happening, realizing what isn't happening, think your way through another consideration going forward without anybody else necessarily telling you to do this versus that as you work through it all.
Okay. And another thing that's on here is high levels of working memory and attention. One of the rationales I have for this might be challenging for people with aphasia is that while you get, let's say you get the word I, then you have to go to this button here for it to find the verb you want. Then you have to remember the rest of the sentence that you have to find. Do you think that would be challenging as someone with aphasia, either early on or now?
And that is true too. When I was presented with my keyboard, I actually would get to the I. I'd actually be put in front of the computer just like this and say a certain word. I want to drive. That's because all of us with aphasia want to drive, but we can't. So I got as far as the I. And I remember sort of freezing and saying, okay, what do I do next? I just got as far as the I. And again, that was the beginning of me understanding that there were these deficits that would have to take time to get better.
Okay, thanks, Tom. So let's go on to VSDs. So same thing, same idea. We've got a VSD here where I like to use this one because it's got me and my son here on his first birthday, and he does not like that his hands are dirty here in this picture. And we just got the navigation ring with other personalized stories, some text supporting this story, the speak buttons and so forth. So it's organized based on personalized stories from my life experience. So I guess I'm building a VSD for later on if I should need it, if you will. Okay. And so Tom, can you talk to me about this interface design and what you think about this and whether it would be helpful either now or earlier on in your stroke experience?
Thanks again. It's always interesting because I have to, all of us with people with aphasia, as we get better, we have to describe what we had thought we had seen before, giving you our ability to express it now about before. So when I began to understand how I was getting better, it did turn out that, like you have here with the video component, this display, an awful lot of my getting better had a lot to do with the images, the visual component of the way I thought through things. So the autobiographical component, what I call the salience component of that, had a lot to do with my pre-stroke life. So everything that was happening in front of me then, now that I describe it now, then, that I couldn't do A, B, or C on the inside because I had my memory, I could remember what was happening about one thing that had to be fixed, as it were. Obviously, fixing my language was another thing, but still that verb fixing was still an issue. Then I began to think that there's a lot of things that I could consider fixing by considering them metaphorically in my mind. So again, being able to really realize who I was before, and then using those same skills to help me get better after my stroke was a large part of the autobiographical component. Without me even knowing that at the time. Of course, none of this that I know were highly therapeutic. Those visual things did provide me with the tools without knowing that they were therapeutic at the time. So yes, if somebody were to provide that to me now, back then, I probably would have liked it a lot more because I wouldn't have to be picking on the keys that you can get from the visual.
Okay. And what do you think about this and thinking about what Dr. Fried-Oken was talking about with like the mobile technology and the Zoom and how this might help people with aphasia? Because you've talked a lot recently about how, you know, people with aphasia have been social distancing way before it was, there was a pandemic. So maybe you can talk just for a second on how this type of interface might be helpful in those types of communication capacities.
Yeah, all of it helps tremendously. Zoom helps these days, believe it or not, although we all still would like to go back to face-to-face, but I'm sure that we will use Zoom much more regularly, just so we don't have to travel quite as much as before. But all of Zoom, because you have these interactions with your friends, with 50 people in front of you, it becomes highly therapeutic without really knowing that it's therapeutic, and this is all practice. So I made plenty of presentations, and afterwards people would come up to me and say, well, Tom, this is good that you do this, but is this still, do you still have to practice to get better? And I had to point and say, what do you think this is? This is practice. This is practice for me right here today. You have to really realize that everything you're doing now, because you have stroke and aphasia and you still make errors, this is practice right here in front of me. So this is how we do capitalize everything we do with the mobile and AAC type devices going forward as one more tool of all the high and low tech tools that we need to help us get better.
Okay, thank you, Tom. So I think we can go in, that goes perfectly into what you want to say here.
Oh, that's good. The thank you very much, Amy, and thank you to G3 ICT. Those are acronyms that in the early days I couldn't pronounce. SLP, never mind Ph.D, never mind IRS, although I could understand IRS. I don't know why, but I could understand that. But I want to thank you both and NeuroAbilities for including people with stroke and aphasia survivors. I was a dean when I lost my language, and I really appreciate being part of this research process with your company. My therapy, at the very beginning, my therapy was my only world. I didn't know what else to do other than the 1 hour a week of my therapy. But as time went by, I didn't know that what I was starting to do was also highly therapeutic. I started walking a lot, and as I walked, I started to see the world differently in front of my eyes. I took hundreds of pictures of the world around me and started to realize that I could see some things, meaning I could see and interpret and understand some things, but I couldn't see other things. But yet I could see both of those things. And that too told me that something was going on. I started recording my voice, and I did that for 2 years without knowing what my language would look like, because when I listened to myself that day, that moment, it sounded fine to me. And it wasn't until it was transcribed years later when I got to see what it was I was trying to say. I started a diary. It turned out to be a 500-page diary with 200 pages that didn't make any sense at all. Since I, quote, couldn't write, the fact that I was actually writing, it was the activity themselves, which was highly therapeutic without me knowing that what I was writing didn't make sense. But I did use graphs, charts, and metaphorical drawings that did make a lot of sense going forward. And as I was walking, I started reading signs out on the road. And that too told me that something was wrong that didn't have a whole lot to do with my words themselves, because even though I couldn't read longer sentences, paragraphs, books at all, I could read individual words like the stop sign and the speed limit sign, and began to understand that there was a lot more that was going on with me than the words themselves. I even had my own AAC toy. Of course, I didn't know that at the time. I didn't know it was an AAC, but my daughter did buy one of these toys that had letters that when you hit them, then they sound like the letter. And like I say, and as a result, it was still therapeutic in its own way. That was a lot of fun, actually. The next thing I did, and this is all me, while I was still with my individual SLP, I joined the local Boston Education and Social Aphasia group. That was also fun. It also turned out to be fun in therapy, and therapy turned out to be fun itself. Again, and so much of what I talk about what happened to me without knowing that what I was doing, probably based on my habit and the world around me, was therapeutic. I didn't know that what I was doing was therapeutic, but it did turn out that fun was therapeutic. And the issue was that speech therapy is short. I was really lucky. I got 15 hours of therapy. That's not a lot. And aphasia recovery takes a much longer time. As I thought my way through this and realized, again, without knowing, that I had built a structure that survived beyond my SLP, beyond my conventional therapy. And that is what I now urge today, that all of these stimulation tools, including AACs, must be brought to bear earlier in what become a lifetime effort of aphasia recovery, with that structure, habitual structure, to help you live your life based on the structure that the SLPs will have provided at the beginning.
Okay, and that leads us to future directions. And as Tom and I thought about these neurotechnologies, or AAC, we both thought it was important to emphasize a key point, And I know this came up with all the panelists as we were preparing too, and thinking about neuroplasticity, and that AAC can be implemented as a dual purpose tool in aphasia. It can be used to help compensate for communication breakdowns and facilitate language recovery. And my little neuron friends agree in their little fist bumping here, saying, feeling the fire between us. We can do this, and it's all a matter of how instruction occurs. That's a whole other talk we don't have time to get into today. But long story short, because we want time for questions and answers session, that if you combine AAC instruction with AAC with instruction on how to self-cue for teaching them how to self-cue words using the AAC system, you can get improved spoken language. And recent work in my lab has shown that you can actually induce neuroplasticity. That's why I have this beautiful brain with all this white matter showing over here, because we can actually change the brain, and we're starting to identify unique neurobiomarkers of AAC-induced treatment plasticity, which is really cool stuff in people with aphasia. So to Tom's point, it's a lot of hard work, but we can change the brain, and then you only plateau if you stop working. And so I think, Tom, do you have anything to add to those points there?
No, I do appreciate the dual purpose tool of AACs, because I also did begin to understand that, at least what I had seen in the clinical work, that for the most part, the AAC was supposed to be just for those people that are chronic, not realizing that even the act of the AAC instructions just to get into some of those applications is still highly therapeutic, is still highly learnable about without even getting into the activity themselves. So I do think that the AAC happens to be just one of those additional but highly useful tools that can be used even from the beginning, even before you're unaware that what you're doing is going to help you going forward. So again, building that habitual structure that includes AACs is very helpful.
Okay, so that wraps it up for us.
That was excellent. Excellent presentation from everyone. We do have some time for some questions. I do have a quick one, Amy. I think this is for you. In regards to AAC and the price, that can be pretty expensive from my knowledge. Are there apps now that are cheaper that can be used?
Oh, I have a website I can give you. I have a former student who I hope is going back very soon to get her Ph.D. She has created a feature matching tool for people with aphasia. It's based on the Boston Children's feature matching tool for people with physical challenges. That's more of access feature matching. She created one for people with aphasia. Nice. And you can put in free versus paid apps, and it even feeds out English versus Spanish speaking apps. And I'll give that to you to give to the attendees. And you can put in all the different features you want for your apps, and it spits out the apps. It's for, currently it's for Apple, for iPad only. She's working on a Droid version. So I'll get that to you in just a second.
Excellent. Thank you for that. So Melanie, do you want to just open it up? There's a lot of Q&A, a lot of chat going back and forth. Thomas, I must say that your presentation was phenomenal. Your courage and your transparency. Cheers. Truly amazing. So Melanie, if you want to kind of summarize some of the questions that have come in, if you feel comfortable doing that.
There have been a lot of questions by individuals who themselves experience aphasia and language challenges. I'm glad that this is a forum where everyone feels comfortable in presenting their opinion, as well as some of the challenges they experienced during recovery. Our goal today was to present one perspective on neurotechnologies. For sure, we could have gone in so many different ranges, from the beginning of recovery to what happens 3 years later, to different philosophies for how aphasia treatment should be planned. What I will say in response to many of the individual questions is this is a personalized trip. We have to come up with neurotechnologies or cues or AAC systems that meet your challenge, not that meet the general challenge for people. Individualizing neurotechnology options and your treatment plan is going to be the best. And hopefully you find someone who can help you in that journey. Just like how Dana was able to help Scott in his journey of using brain-computer interface and an alphabet system, depending on what he needed in what setting. All of us have to individualize our communication systems based on the strengths. I'm going to ask Rachel. Rachel and I had decided that Rachel was going to give some of the questions. So I'm going to thank the panelists and everyone listening and let Rachel take it away.
Super.
Okay, yeah, so we did have quite a few questions, and I see some of our panelists are typing answers to them. So I'm just looking. Let's see.
There's one, Rachel, that this is Christopher, that I love to hear people's perspectives, the panel perspectives, and that deals with technology as a whole. Do people with aphasia have trouble understanding how to use technology? And I've seen our comments around this point, how difficult it is to actually use the technology. Any thoughts around that?
So yes, we definitely cannot just give them the technology because there's the learning of the technology, then there's learning how to use it to communicate. So it's dual pronged. You have to, one, learn how comfortable are they with the technology, and then handle that piece, and then teach them how to learn to use it, how to communicate. So, and then if they're not comfortable with technology, maybe you need to go low tech, because you can still teach them these skills with a low tech option, like a communication book. You can still do visual scenes in a communication book. So if the technology is an issue, you can do low tech. But research shows over and over, you have to have instruction. You can't just give it to them. So that's number one. And it does require some skill to do that. So I do think we expect that we just give it to them and it's going to be intuitive for people to learn how to do it. And it is more than just pointing, because what we do know that if you just point and you don't pair it with trying to talk, that is where, we don't want to do that, because if we do that, then that's where you start replacing speech with pointing. And my research is starting to show that if you pair pointing to it or having the device talk while at least trying to say it, even if you can't, then the brain starts to try to rewire, even if you're not saying it. So that's where that critical instruction comes from. So this is the research that we're trying to get out so that SLPs are getting this. And so this is kind of like my mission right now, is to help SLPs understand that. But the research in aphasia and AAC is really just, I think, starting to come around to this. It's something that I know when I came out to get my PhD, it's not something that I really even understood. It's why I came back, really, because someone got mad at me and walked out because I handed them AAC after they said they plateaued. So it's really something that we've not done a great job of.
So another question real quickly, we're coming towards the end. In regards to getting access to AAC, maybe Brett, this is more for you. Are there loan libraries that you can try before you buy this equipment? Because again, it's expensive. It does take time for training. Do the assistive technology projects out there under ATAP or RESNA support some of these loan libraries that you're aware of?
So the organizations that you listed don't support loan programs. Their availability and affordability are major barriers for many individuals, especially in developing countries. One group that we should connect with is the International Society for Augmentative and Alternative Communication. It's known as ISAAC, ISAAC, and ISAAC does have initiatives to work with individuals in developing countries around AAC and advocacy for insurance or other financial supporters.
Great, thank you for that. Anybody else on that one comment? We have come to the end. Okay, well, thank you so much. This has been an amazing panel. The participation from the participants has just been amazing. Thank you all, Thomas, Amy, Brett, Dana, and Melanie. Thanks for moderating this. Do stay in touch with us. I want to thank the G3 ICT team. I want to thank our sponsor, the Patrick J. McGovern Foundation. I want to make sure that we recognize our captionist who's done a great job throughout. And stay tuned with us. Make sure that you check us out on our YouTube channel as well as on Twitter. Thank you very much. And have a great rest of the day.
Thank you very much. Take care. Bye.
Bye.
Bye, everybody.
Thank you, everyone.
Thank you, everyone. It was awesome.
It really came together so well. Every single person offered new insights that made it even better.